Assalamu alaikum. I am AM Hidayatullah Malik. My student ID is 213357888. Today our discussion topic is AES, which means Advanced Encryption Standard. Now I will explain the code of AES. Here at first, Archon is a list containing the round constant used in AES key expansion. Then comes the S box. S box is a 16 into 16 substitution box used in AES encryption. Then key to generate prompts the user to enter the number of rounds keys to generate. Then matrix is initialized as an empty list. Then a loop prompts the user to enter the values for each row of the matrix in hexadecimal format, which are then converted to integers and appended to the matrix. Then last column is created by extracting the last column of the matrix. Then the first value of last column is popped and appended to the end, uh, simultaneing the circular shift operation. Then a new column is initialized. A loop interacts through each element of last column, and for each element, its hexadecimal index is determined, then used to look up a value for the S box, and finally appended to new column. Then previous column is created by extracting the first column of the matrix. Next round key is initialized as a 4 into 4 matrix filled with none. Then a function fill next round key is defined to fill the next round key matrix with the provided column values. A new list new matrix is initialized. A loop iterates through each element of previous column and new column, performing XOR operation with the corresponding element from recon for the first element and simple XOR for the rest. The result is appended to new matrix. The fill next round key function is called to fill the first column of the next round key matrix with the values from new matrix. Another loop iterates 3 times corresponding to the remaining columns. Inside this loop, a new list, new column 1 is initialized. A nested loop iterates through each row of the matrix, performing XOR operation between the corresponding elements of new matrix and the next column of the original matrix. The resulting values are appended to new column 1. New column 1 is copied to new matrix. The fill next round key function is called to fill the respective column of the next round key matrix with the values from new column 1. Finally, the next round key matrix is printed in the formatted manner displaying the generated round keys. Now we have to go to the output section. Here we can see plain text, the next round key. Here we have selected for our output for round 4, and here the first row's value is B05EAC41. Then the second row values are 2BF6DB25. Then row 3 values are 3C7ACE36. Then row 4 values are D4B7FD and 71. This output represents the next round key generated according to the provided input and the code. Each line represents a row in the next round key matrix. The numbers in each row are the hexadecimal values of the round keys. Each row contains 4 values corresponding to one round key column. The first column of the next round key is 872E, 9F, and 57. These values were obtained by performing XOR operation on the first column of the original matrix, previous column, and the newly generated column, new column, derived from the circular shifted last column of the matrix using values from the S box and recon. The second column of the next round key is D9, D8, E5, and E0. These values were obtained by performing XOR operations on the first column of the next round key and the second column of the original matrix, similar to the first column. The third column of the next round key is 75032B1D. These values were obtained by performing XOR operation on the third column of the next round key and the fourth column of the original matrix. These steps follow the AES key expansion process where each round key is generated based on the previous round key and the original key output. Overall, this output represents the next round key that would be used in the AES encryption process based on the input provided and the code logic. That was for today. Thank you.